Always
How's it
good to see
going?
you.
Yeah, good to see you. Uh, I was going to talk today about speckles. How do you feel about that?
Ooh, that sounds
Mhm.
exciting. I like sparkles. Sparkles? Do we get to do
Yeah,
sparkles?
we can be it can be sparkles.
Oh,
Sure
I
can.
love sparkles.
Yes. Um, CellProfiler and Sparkles or Speckles and I have a long history because the first thing I started using CellProfiler for in graduate school was trying to find telomeres, which are little bright dots in the nucleus. And so I have a lot of history of figuring out how to try to make speckles nice in CellProfiler. So thought I would share a few tips and tricks.
Yay. Can't wait.
Yeah. All right. So I pulled this data from the IDR, one of our favorite places to find publicly available data. And this is an experiment where they have nuclei and they actually have four different colors of speckles. So if I change these to grayscale, speckle channel one, this is nuclei, another speckle channel, another speckle channel, another speckle channel. Not necessarily all the same speckles. Yeah, I didn't mean to do that. Um, so here we have like these three dots that are right there. Looks like we do have those same three dots in the next one, but is very different here. So we have spots sort of in different things. Um, and but it turns out that spots is something CellProfiler can do actually quite well. Um, so I have that data downloaded, just a sort of small subset of it, and let me pop in the CellProfiler project that I've already sort of pre-cooked. Except this is not the one for this episode.
Sparkles. We're on sparkles right now.
Yeah.
Hey.
Um, we believe in being prepared around here. So
At least
here
giving the
are
illusion of it.
yes. So here is my sort of pre-baked cell profiler pipeline. All I've done ahead of time is to set up my names and types modules, and we'll put this pipeline up as we always do, as well as the images that I'm using here. And I've just thrown in a gray to color module, not because we actually need it, but just to show you that, yep, there's our thing. Here's all of our stuff. That's what it would all look like together. But we don't actually need this. This is just for visualization. But if we wanted to say put some outlines on things later, we could do that.
Yeah, I will point out to another place that one can do that is in the workspace viewer.
Hmm.
That is also a really handy way, much like you just showed us in Fiji, being able to toggle on and off the channels. It's certainly uh I think both of us always just start in like you have a new image, like we always just start in Fiji because that's really what it's meant for.
Yeah.
Or
AG is
what
great.
yeah.
Yeah.
But just pointing out that Cell Profiler does have the workspace viewer,
Hmm.
can be handy for, especially as you're going through a pipeline. If you already have images loaded in and you're working on them, being able to toggle that as a workspace, and not just in the modules as you go.
Yeah. I like having gray to color though, because what we can then do is we can make overlays that we can save out. And whenever you're doing something in Cell Profiler, I'm always going to recommend that if you are identifying objects of any kind, that what you go through do is you go through and you actually save those outlines out because it's a really sad day when you have to go to your boss and tell them that you've been chasing a segmentation error for 3 months because you didn't actually look at the segmentations you were doing because you had too many images. It's a bad day.
Yes.
Don't don't be me. Um, so I'm gonna just make some quick nuclei and cells here. I'm gonna drag this down and I'm gonna just turn it off for now because we don't actually need it now. We don't probably need these, but it's nice to have them. And how big are my nuclei? Should also change my visualization settings, which is a helpful thing to do. So CellProfiler has these visualization settings where you can set what the default thing is in terms of being able to see. The last project I was working on was really dark, and so log normalization was helpful to make it so the images were actually visible. Um, Normalized is CellProfiler's default though, and for most things it works pretty well. There we go. That looks
Oh, look at
amazing.
that.
Um, so if I want to get a sense of how big my objects are, I'm going to just grab CellProfiler's length measurement tool and I'm going to click and drag across this nucleus and get an idea of about how big it is. So it's about 100-ish pixels in diameter. So That is going to help me. This should be pretty easy to segment, I'm guessing. Um, because these are sort of gorgeous nuclei. Yeah, gorgeous. I'm gonna just change this bottom number a little bit because it's over segmenting them a little bit. Beautiful.
Look at that. Wow.
Nuclei are so nice.
So lovely. And I mean, look at CellProfiler. Like just
Mhm.
by taking in a couple little settings, it's able to output default parameters
Mhm.
that
Yeah,
find your nuclei.
yeah. And just so that then we could associate spots with cells or something like cells, we don't have a whole cell channel here. I mean, some of these you can kind of like squint and maybe see the cytoplasm. I don't know if I'd trust it that much though. But what I can do real fast is if I want to make some sort of pseudo cells, and maybe in fact I'll even name them that, I can use CellProfiler's distance B method, which involves saying, I'm going to make an object and then I'm going to draw a donut around it. Uh, and hmm, why did that not work? Um, oh, because I wanted distance N, not distance B. So distance B is make donuts, but also threshold into areas that are threshold positive. And CellProfiler, quite rightly, was like, there's nothing threshold positive outside of what you've already identified. Um, touche, CellProfiler, touche. So here are my expanded pseudocells. Easy peasy. These should be good enough. All right. Um, a couple things about making speckle images. The first thing that is super helpful for you to know when you do this is that there is a module called Enhance or Suppress Features. Enhance or Suppress Features allows you to either enhance or suppress features in your images.
Whoa. Whoa. Crazy naming system you've got here, Beth.
Um, so what you can do amongst various different kinds of things is enhance speckles, which is what we're going to do here. And we can tell it, hey, my speckles are about this size. Anything that's bigger than that, I don't want. Um, And now this looks like nothing because um, it is very dim, which is why we should reset our normalization settings again. So let's figure out what those might be. What are some good normalization settings here? Um, normalization with a parameter of 5. That sounds great. And if I apply to both of them, um, hmm, that should hopefully work. But so can see already even just a little bit, but now let's try to make it much more obvious. So it's not uncommon, at least in my workflow, to be changing this, what is my default display setting, several times throughout the course of like building a pipeline. Um, and it just makes life faster. And anything that makes a step that you're going to do a bunch of times faster, like configuring things, the better your life will get. Um, So now we can see that we have this spot that was previously on the background of a whole bunch of stuff that now we can barely even see anything because all of that background has gone away and we just have our lovely little spot. It looks like we now don't have anything, but in fact we do have things. We just mostly have lovely little spots. Um, I suspect that that is gonna be good, but we'll take advantage here of the workspace viewer and the fact that the workspace viewer has a property that the rest of CellProfiler does not have, which is when you rerun a module, CellProfiler will default to just showing you um, go back to sort of the zoomed out view. What if you want to stay on the zoomed in view? The workspace viewer is actually really helpful for that. And so here's what the sort of very zoomed out version looks like with our current settings. If I want to just sort of change my feature size just to get a quick sense of if this got better or worse. I now have to go back and find that same thing over here, which would be hard. Um, but in the workspace viewer, it stays in the same place. That looks worse to me. If I go to 15, hmm, that's an interesting bug. Um, hmm, all right. 10 was working, so
It's funny. I feel like you and I both have used enhancer suppress features a lot.
mhm,
But that's the beauty of live demonstrations, like finding
mhm,
bugs that we've never found before.
yeah. 10 seems good. We're gonna go with 10.
Okay.
Um, so, um, if I then wanted, I could do the exact same thing by just using CellProfiler's duplicate functionality and just make spots the same size of all of my channels. Um, Now, it might be, I don't actually know the biology here, that we would expect that some of these RNA foci would be bigger in some cases than others. I don't know why we would expect that, but if we did, I could go through and I could adjust this feature size. But um, and yeah, we can definitely see in some of these brighter ones. Seems like one was our dimmest one to start with. Just how much like we are keeping our real signal, but everything else just sort of like goes away in a way that is super lovely.
Yeah. And that is also something, again, with here we're sort of guessing at the biology because that's not really what matters for this demonstration. We're demonstrating proof of principle here. But in any situation, you want a biologist with actual domain knowledge that can tell you about what they're looking for, because perhaps some of that tiny, tiny graininess, maybe there are spots that are only 1 or 2 pixels wide in those images that actually do matter to capture. Or maybe it's really only the bright honkin' 20 pixel wide foci that are, way fewer and that are actually what we want to find. And so being able to talk to the biologist or get more information about the biology we actually want is an important thing when you're extracting actual information. Um, yeah.
Uh, and I want to sort of talk about that was all incredibly good point. The one other thing I want to sort of point out in regards to speckles, it's going to be helpful for me to show you what the image histograms look like. So here's the image histogram from our nuclear channel. You can see that we have low pixel intensity, which is our background. We have lots of pixels. And then we have this sort of second bump. Cool. Great. What does it look like, especially once we have speckle adjusted our images? Yeah, we don't have that here. So most thresholding algorithms operate on the principle of that you're going to have two or sometimes more of these peaks. And what they're trying to do is to figure out, where do these peaks cross? If you don't have that, how do you actually properly threshold your image? So CellProfiler has a neat little thing that Anne Carpenter actually invented this thresholding method. True story.
I
This is
didn't realize that.
yeah. Where it has a special thresholding method called robust background, which is great for when your image is mostly background. Um, so um, I did not realize that for a long time either. Um, so I think our speckles are probably going to be between sort of like 2 and 10 pixels. That's going to be my initial guess. And actually, I'm going to start with like one of the brighter ones. I'm going to start with channel 3 because why not? So the way robust background works is it says, all right, I'm going to clip off the very dimmest pixels and the very brightest pixels. And I'm going to figure out sort of then after that, like what is the mean and of that distribution that is left? And then say, how many standard deviations above the mean would you like to say is your threshold? And so if your stuff is super bright, sometimes I've set this as high as like 10 standard deviations. Let's start with something more reasonable, like 4. But hopefully this is going to do a lovely job of picking out just our speckles and nothing else. All right. Um, so here we actually do really have super lovely signal where even 4 standard deviations above the mean of the background is still picking up a lot of crud because our spots are just so, so bright. So 4 standard deviations above the mean is giving us about 0.008. Our actual pixels are like 0.06. They're zero point 0.1 in some cases. They are way brighter than that. So all I have to do is say more standard deviation. So let's say 10.
And
Great.
Beth, would you ever bump the outlier fraction?
Um, yes, potentially. So if you know that your image has like some autofluorescence or some crud in it that you really want to sort of work around, you can change that outlier fraction. More often than not, though, what I have found is if you're in a regime where you're changing the outlier fraction, that means that enough of your image is signal such
Hmm.
that you should probably just switch thresholding methods. So sometimes I will play around with that if it seems like we're pretty close to sort of having something where we have a single peak after clipping that is only our background. But with time and experience, I have done that less and less. All right, this looks great. Um, Again, if we sort of really understood the biology we were studying here, we would know if we want these sort of bigger things or not. I'm just going to err on the side of assuming that we do, and I'm actually just going to turn off the discard objects outside the diameter range. Um, but yeah, we now have our gorgeous little speckles.
Look at that.
And so what usually we will want is some kind of, measurement of our speckles, maybe. So in our speckles channel 3, I might want to get all of my different unprocessed. Want to clarify, always want sort of unprocessed when we're doing measurements. Um, and then what I can do is I can use the relate objects module to say I have these cells and they're going to have speckles inside them. And I want to know um, how many speckles and what is the average speckle intensity or whatever measurements I've made for each cell. So that way I can know if there's something about my cell, like maybe big cells have brighter speckles, or maybe there's something about ones that have super bright speckles in channel 3. Um, and so to just sort of show you in the workspace viewer what that looks like, if I now just pull up my DNA image, um, I can show you my pseudo cells. Um, I can show you my channel 3 speckles, and I can throw that other speckle channel on here, um, just so that we can sort of see what that looks like. But then I can also do things like say, hey, for each cell, show me how many speckles are in it. And I probably don't need that to 4 significant digits. Um, but yeah, now I know for every cell how many speckles it has. And if I zoom in, um, yeah, that looks to me like I've caught things.
Awesome.
So if this were really my biology, all I would basically then do is sort of duplicate this module 3 more times, duplicate this module 3 more times, add the rest of my objects here, and then make some outline channels so that I could go through and actually take a look to see. Um, but in the interest of time, you can see that in many of our other videos, those sorts of things. But the sort of tricks around how do you do speckle enhancement and what is the best kind of thresholding for speckle enhancement are what is really special about this workflow in particular. You can also check out our example speckles pipeline on cellprofiler.org/examples, which has a speckle example that you can download and try, but you can always download this pipeline and these images from our website.
Yay.
Anything to add here, Erin?
No, I mean, I think very sparkly. I mean, just, I happen to like workflows where you identify lots of objects,
Mhm.
especially the outlines, because you can give each of them a different color, and then you have these like yeah, I mean, I think you like there I had a workflow where basically told me it was too psychedelic. You couldn't interpret any of my object outlines because there were too many objects and too many colors, and um, you'd never guess that that was a thing I liked. But again, a handy thing to remember that it can be really helpful for interpreting after the fact what your outputs are and what you're seeing.
Yeah. Realistically, with this many channels, what I would probably do is rather than putting the object overlays on a color image, I would make 4 different overlays, one for each channel, just so that I could then really interpret them, especially because it seems like we have bleed between some of them.
Yeah. Yeah, but definitely something you can play with depending on what your biology is, right? Like your question can inform what you're doing. If really what matters to you is just count, then that may be a very different, very different sort of object overlays that you would look for if you were looking for more complex relationships, more, intensity-based relationships, and so your biologist knowledge, again, would be very important for the final choices that you make in such a pipeline.
Great. Great. Thanks for hanging out with me, Erin, while I did this. It's
Of
good
course.
going back to old times and thinking about Speckles again.
Yeah, thanks for bringing sparkles into Ask Erin, Dear Beth.
Always. All right. See you later.
Bye.